Hey everybody, it's Travis speaking. Today we're going to break away from the Autodesk applications and we're going to take a look at another application used for programming the VEX Robotics kits. So what I have here today that you can't really see right now is a robot that I've assembled, and I've got that plugged into my computer, and I have another program here called RobotC. So to get started with a program, one of the first things that you're going to want to do is make sure that you have the right firmware in place. So if you go to the VEX Robotics web page, you can locate the firmware installer. So I'm just going to bring that up here. It's under, that would be Innovations First, and the VEXNet Firmware Upgrade Utility. So I'm just going to open that up quick. And it's saying that it's up to date and no action is required. If you have your Cortex plugged in and you open up this utility, and if your firmware isn't up to date, it's going to tell you that you need to download new firmware. So that's a pretty simple process and takes about 15 to 30 seconds. So again, if you require this new firmware, you're going to want to go to the VEXRobotics.com website. So I'll just close that down for now. Now, again, the one thing that you're going to want to have done when you've already started it up is take the orange USB cable that you'll get in your VEX Robotics kit and plug that into your computer, and then plug the other end into the Cortex of your robot. Then you open up RobotC and we'll get a new file started here. So what you're seeing looks a lot like HTML. It's a C-based language, and the RobotC software allows you to compile a code that you're going to send over to the Cortex of your VEX robot. So the first thing we're going to do, we're going to come up to where it says robot, and we're going to choose platform type, and under platform type I'm just going to choose the VEX 2.0 Cortex. So once that's done, I'm going to come back up to robot, and we're going to say download firmware, and we're just going to choose this automatically update VEX Cortex. Okay, so it gives you a message here. It says this utility will automatically detect your VEX Cortex and update it to the latest firmware versions. Before we proceed, make sure that your VEX Cortex is connected via a USB A to A cable to your computer. We have that done, so we can move on. We'll click OK. And you'll get this message right here, and it's just going to download what it needs to. We'll let that happen, take place, and then it says that it was downloaded successfully. Okay, so the next step is to determine what do you want to do, what do you want your robot to do. So today we're not going to get anything too complex. We're just going to give our robot some commands on moving forward and turning. So what you'll want to do is develop basically what's called pseudocode, and pseudocode is the logic that you have in your head in your human language, and you type that out or you write that down. You can just jot it down on a piece of paper, but when you want to enter it into your code, there is a symbol that you need to start it off with. So to start some pseudocode, you type in a slash and then put in an asterisk, and then you can put in whatever else you want to put in. So maybe you want to put in your project title. We'll call this YouTube example. So essentially what this means is if it has this asterisk and the slash, it means that the robot isn't going to look at it as something that it needs to do. Okay, so I guess what I want the robot to do is I'm going to want it to move forward for 5 seconds, and then I'm going to want it to do a point turn right. So what a point turn is essentially is you have one set of wheels or one motor turning, and then your other motor working the other side, the other wheels, isn't moving in motion. So it's kind of similar to a tank. If you think about the way that a tank moves, you have two motors or two sets of tracks moving forward, and then if you're going to turn, you can have one set of tracks moving one way and then the other side moving the opposite. But if you want to turn on a point, that means that you're going to have that opposite direction for the motors. And then you could have a swing turn, which is a little bit different. That just means that one set of motors isn't moving whatsoever. So it's going to be a little bit wider turn if you're doing a swing turn. So we're going to do that point turn right, and we're going to say that's for 3 seconds. And then we're going to do just a forward motion again. So we're going to go move forward for, let's say another 5 seconds. And then we'll do the swing turn. We'll try that out. Swing turn left for 3 seconds. And then let's make it move backwards. So we'll go move backwards for another 3 seconds. Okay, so this is just for my knowledge, just so I know what my robot's doing. So again, now to close this off, I'm going to put in another asterisk and another slash. So again, this isn't going to tell the robot to do anything. This is just basically a guideline for me. Okay, so now that we have our pseudocode done, we're going to essentially set up our motors. Now, if I take a look at my robot here, I have my motors plugged into ports 3 and 4. So we're going to need to establish where the motors are going to be. So we're going to come up to Motors and Sensor Setup, and if we come over to the Motors tab, you'll see that we have all the ports for our Cortex. So I'm just going to come into port 3, and I'm going to call that right motor, and port 4 I'm going to call it left motor. Now if you have a specific front and back to your robot, you're going to want to make sure that these motors are named and defined accordingly. For my robot here right now, it doesn't really matter which way it is front or back. It'll just move according to how we set up the motors. So from here I'm going to choose the VEX 393 motor, and I'm going to choose the VEX 393 motor for this one. And on my right, I'm just going to check this as reversed. So now what this means is that the one motor is going to be moving forward, which is the left, and the right motor is going to be moving in reverse. So this might seem counterintuitive, but this actually means that both motors are going to be going in the same direction. If I didn't have this checked, it would mean that they would be going in opposite directions, and then if I give it a forward motion in the code, it's just going to spin in a circle. So I'll check that back to reverse, and we'll say OK. And now you'll see that up here at the top, we've got a line of code here that defines our motors. Okay. So let me just see here. Now we've got our motors set up. Now we need to actually define the other part of the code. So in the sidebar here, you've got some other motions essentially. These are little variables that you can put in. You can drag and drop these, which are pretty great. But I'm just going to show you how to write out the code. So I'm going to skip a line just to keep it clean. And what I'm going to want to do is enter a series of commands. So it's going to start to look like this. We're going to say motor, and one of the nice things about RobotC is as I'm typing this out, it's giving me drop-down menus that I can use. But I'm just going to stick to typing these out. So I'm going to say motor, and then I'm going to put in a square bracket, and I'm going to say left motor, and make sure that you name the motor according to what it looks like up here at the top. So I say left motor, and my square bracket, another space and an equal sign, and then I'm going to say 127. So 127 means full power. If I typed in negative 127, that would mean full power in reverse. But as you can see from my pseudocode here, I actually want to move this forward. So the motor, left motor equals 127 is saying, okay, robot, please move this motor at full speed, but you have to define the time that it's going to move forward at that full speed. So again, I'm going to type in the other motor here. We need the left one. So I'm going to say right motor space equals, and then I'm going to say 127. Now, if I didn't check the reverse, I could do the same thing here by putting a minus in here, and this would cause both motors to move in the same direction. But because when I set up my motors, I checked off the reverse, and it's made them alternate directions. So I'll leave that as is. And then now we have to define how long this is the motors are gonna go forward for. So we're gonna say wait 1 msec, and then in a normal bracket we're gonna give it the time. So if I'm using the 1 msec, as you can see here, that's your 1 millisecond. So I'm gonna put in 5,000 for 5 seconds, and then close the bracket. And then I'm going to put in the semicolon. So one thing that I like to do as I'm creating my pseudocode is I'll put in my my lines over here. For the time being, I'm not going to do that though. One thing I made a mistake while I was telling you about this is that you're actually going to want these to be doubles. Did I do that right? And to remove that asterisk. Nope. Oh, I just goofed something up here. Well. Why don't I redo this? So, as I mentioned, typically I'll put this code, the pseudocode, after my actual code. So I'm going to type in the double brackets, move forward for 5 seconds, and then my asterisk. So one thing you can remember is it's showing you some pseudocode up here, basically just for your information. Once you configure your motors, you can take a look at this. So what you want your pseudocode to be is fully green, and then you'll know that it's not going to take that as a command or part of your code. So now that we've got the first part of it set forward, we're going to do another one. So again, what you can do now is take these and copy and paste them. So I'll just grab all of this, I'll come down another line. And so if the second line was supposed to be to move, what I'm going to want to do is put a pause in here. So the pause is going to look, well, I can use what I have here. The pause is essentially stopping the motor. So in this case, I'm going to change that to 0 on both of these. And I'm going to change this, if I want it for just 1 second, I'm going to make that 1,000 instead. So half a second again would be 500. But every second is 1,000. So now both motors are going to stop before they do their swing turn. I'm going to copy over 2 more motor commands, and we wanted to do a point turn right. So in this situation, if you can recall what we were talking about with switching the motors over, I actually want both motors to go in an opposite direction. So I'm just going to put a minus on my right motor, because we wanted it to turn right. So that means I'm going to want the right hand motor to actually move in reverse while the left hand motor moves forward. But I don't want that to go for 5 seconds. I'm just going to do that for 1 again. Well, maybe 2 seconds. And we'll see afterwards how far this, how it moves on a point. So now, as you go along, you're going to want to modify your pseudocode as well. So in this situation, it's actually going to be, we're going to just take that out and say pause for 1 second. And in this one, we'll call this point turn for 2 seconds. Forgive me if I'm not as quick on the RobotC as I am with the Autodesk software. This isn't really my forte, but it's still some pretty interesting stuff. And if I can get these robots to run, I'd say that's pretty evident as to just how easy this stuff is. So where are we at here? We wanted a point turn, and then we wanted to move forward again. So I'm going to come back to my forward command, and I'm just going to copy and paste that and bring that back down here. Now maybe I don't want this to go so fast this time. So if I want it to go at half speed, I could change this to a 63, and that's halfway to full power. Oh, not 632. 63, and this time I'm only going to move it forward for, say, 3 seconds. So I'm going to move forward. All I need to change here in my pseudocode is 3. And then the last thing, I think we wanted to do a swing turn and then have this move backwards. So the swing turn is going to look like this. I'm going to take this 2-second turn and copy that down. Now in this situation, you could do a combination of things. Maybe you still want the left-hand motor to move, but maybe at half speed. And typically if you're going to do a swing turn, you're going to do one side at least full speed, and maybe the other one at 0 or half speed. So it lets it turn at a more aggressive angle, you could say. So I'm going to change this one to 63 and then leave this one at 127, and then I'll make this 3 seconds. So again, I'm just modifying my pseudocode so that if anybody comes into my code afterwards, they're going to see what I'm doing here. I've got a good outline as to the human logic behind this. So I'll leave that at 3 seconds as well. And then the last thing I want to do is I want to move it backwards. So the easiest way to put in the backwards code is just to grab your forward code. We're going to copy and paste that down here. And now on both of these, I'm going to put a minus in there in front of both motors. And then quite simply, just change this to backwards because that's what I've done here. And we'll say for 3 seconds and change that here as well. So now when that's all said and done, I'm going to come up to a robot and I'm going to say compile and download program. And it's going to ask me, do you want to save this? I'm just going to save it to the desktop, and I'll call it, again, we'll call it YouTube sample. Once I've saved it, oh, it says power cycling. This can be aggravating, but it's actually kind of a good thing for the video. So you guys might not be able to see this, but it's really important because power cycling is it's a snag that can happen, and if you don't know what it means to power cycle it, basically it just means that you need to disconnect your USB. So I'm going to do that. You hear me disconnecting it. And then I'm going to take my battery out. Just disconnecting the battery. And then I plug that back in. And then reinsert the USB, and we'll see if I was able to do it. It says robot controller failed to respond, possibly not powered. Oh, let's turn it on. That will help. Okay, so now I've got my robot turned on because I had it off before. Let's see if we can't compile this. Robot, why don't you communicate? Maybe I haven't selected the right communication port. So if that's the case, USB only. Let's say VEXNet or USB. We'll give that a shot. Okay. Come up to View, select communication port. Just refresh this. I'll leave that as automatic selection. Hopefully this works so I don't look like a fool. Okay, so let's try with disconnected again one more time. I'm just going to power cycle this one more time. Success. So there you go. I mean, it can be a little bit frustrating if you're not sure what you're doing. Believe me, I've experienced it. But once you get used to this, it's not that bad. The power cycling is a pretty simple process. You just turn off the Cortex or turn off the robot, unplug your USB from the computer or from the robot, one or the other. It just can't be connected. Shut off the robot, disconnect the battery, plug everything back in and turn it back on, and then you're going to want to retry the compile and download. And as you saw, it stepped it back in there. So sometimes seeing those mistakes, they kind of help, I guess, deliver the message home. So I'm going to leave that in, and I'm going to start this up and see how it works. So if any of you didn't hear that, that was my robot actually executing the code that I just compiled into the Cortex. I have it up on a hoist, which is something that you might want to do, and that hoist is essentially just an empty box. You just want to make sure that the wheels aren't touching anything, so it's not going to upset anything on your desk or wherever you're working with. But yeah, and then once you have your code compiled, you're going to want to put it on the ground and see if the parameters that you've set actually meet what you're trying to do. So you might be trying to make your robot go through a little maze, and there's some things that you might want to consider, like the battery. The battery, as it drains, it's going to cause your full speed, the 127, to actually be a little bit slower. Other things that can affect your speed or the precision of your turning is how tight you have your wheels fastened onto the robot. Maybe you have some loose parts and that can affect it as well. But anyway, that's just a pretty simple introduction to writing some pretty simple code in RobotC. And if you guys have robots and you haven't tried this out, I strongly suggest it because it's lots of fun and it's a great way of learning robotics and engineering. Anyway, this is Travis Van Cleef signing off. Thanks for watching. Bye now.